purpose of this video is to debunk a lot of the misinformation around diesel charging of EVs that's present in the media. Go through the maths, demonstrate why electric powertrain actually gives you really good efficiency. I'm going to look at a case study, shows that the generators actually do a really nice job, even if you're running on pure diesel. The NRMA system isn't. It includes battery backup, solar, and diesel. So what we'll look at here is a worst case. Almost any circumstance would be better than the case that we'll look at mathematically, but what we'll do is we'll just go through the real basics of what the maths looks like to evaluate whether or not the NRMA generator is doing a good job, whether diesel charging is actually a good standalone solution for EVs. When we go through it, the important part is to make sure that we go through and we look at all of the references, we get real data, we don't just make stuff up. I've seen one journalist who's essentially just gone, hey, here's a random paper on ResearchGate, found 85%, I like that number. Don't do that. It's important that you actually understand what you present. And that's why I've done this, because I think that a lot of the coverage of this NRMA stuff so far has been at best disingenuous and worst, quite heavily biased. So let's just go through the maths. Numbers will speak for themselves. So what I did first was actually find an article which listed the build-up of the NRMA recharging station. So first off, they say that they've got solar panel roof. They don't specify how much, but based on the size, it should be 22 to 25 kilowatts. They also have a charge controller and a battery system, which is about 100 kilowatt hours. Now, on its own, 100 kilowatt hours should be enough to recharge most electric vehicles. But what I did was just assume that we'll take a worst case. For some reason, the battery is depleted and there's no solar. We're in northern Norway in winter, whatever. It won't happen in Australia, but we'll do it anyway. I picked a generator which seemed about appropriate. That's a Hyundai DHY 65 KSE. Generators sold in Australia, by and large, have emissions controls, catalytic converters, DPFs, things like that. They don't comply to car standards because they don't move, so you can't measure them in grams per kilometre or anything like that. But they have their own standards, EPA and ECE. So Hyundai DHY 65 KSE is a 60 kVA generator which can generate 48 kilowatts on a continuous basis. So every hour, 48 kilowatt hours. To do that, it uses 14.2 litres of fuel. And what that works out to be is 3.38 kilowatt hours per litre of diesel that you put in. And that's electrical power out versus diesel in. So that means we don't have to consider any internal efficiencies. It's nice and easy. The charger is a Tritium RTM75. You may see that it listed at RTM50. I don't think there is an RTM50. The Tritium page indicates that the RTM75 comes in two flavors, 75 kilowatt and 50 kilowatt. They also indicate that they have a 95% continuous efficiency rating. I haven't seen a curve for it, but I would assume that that is over a full charge cycle as opposed to a peak. You get in a lot of trouble these days if you start advertising false data. People get sued for that quite regularly. So what I've done is I've taken the lowest efficiency EV that I could, which is a Rivian R1T Max with the all-terrain option. That's not throwing stones at the Rivian. It's a really cool car, but big knobbly tyres, really huge frontal area on a tray means that you're always going to get pretty poor fuel efficiency. And in this case, it's got a 149 kilowatt hour battery, which will get it 568 kilometres on an EPA range rating, which equates to 262 watt hours per kilometre. As a more representative normal scenario, I've also used the Tesla Model 3 just because they're probably the most common EV in Australia at the moment, I think. Certainly they're reasonably affordable, reasonably sized EV. It's the sort of thing that people might buy as a more generic version. That's 75 kilowatt hours for the long range version, which will get you 629 kilometers. That's quite a lot more with a lot less energy. And that aligns to 119 watt hours per kilometer. Now, that means that you won't quite get 4 kilometers out of a kilowatt hour for the Rivian, but you'll get a little over 8 out of the Tesla for the kilowatt. So if we go back to the specific case study we're looking at, and we look at the Rivian R1T, and we take the 149 kilowatt hour battery, and we divide that by 0.95, because we want 149 kilowatt hours in the battery, it means that we need to put 157 kilowatt hours into the charger. So effectively, we give up 8 kilowatt hours to the input for the charge. That works out with our generator efficiency of 3.38 kilowatt hours per litre to require 46.5 litres of diesel to fully charge a Rivian from 0 to 100%. Now, that might seem like a lot, but there are no dual cab utes floating around with a 46 litre tank. There's a good reason for that, and that's because it is really efficient. And as a comparison, what I've done is I've included a Ford F-150 Raptor. It's a good comparison because it is a sort of a very off-road focused vehicle as well, knobbly tyres, all that sort of good stuff. It's a good analogue to that vehicle. A Ford F-150 Raptor, which is roughly the same size and has roughly the same equipment as the Rivian R1T with the off-road pack, gets between 13 litres per 100 Ks, which is highway in the most efficient configuration, all the way to 23 litres per 100 Ks in the supercharged V8, which has roughly the same power as the Rivian. Both are really cool cars. You've just got to pick the one that suits you for whatever you want to do. Now, if you go to the Tesla example, if you look at the 75 kilowatt hours that we need to put in, you divide that by 0.95, we need to put the 79 kilowatt hours into the charger. So in that case, we put 79 kilowatt hours into the charger, we get 75 kilowatts into the vehicle. So we pay for 4 kilowatt hours to charge, and that gives us 23.4 litres to get our 629 kilometres. So again, that's really efficient. So you can buy a Yaris Hybrid, which will actually get 3.7 litres per 100 Ks as well, but it's a much smaller car. It's a really cool car, and I really like them as well. I love all these things. A good comparison vehicle, roughly in terms of size, is a Mazda 3. So a Mazda 3 is about the same size as a Tesla, similar physical configuration, 4 doors, 4 seats. It's not quite as high spec, but it's a good car. Typically, they get 5.5 to 6.6 litres per 100 Ks, depending on the spec for the vehicle. So you can see that the Tesla's getting nearly double the fuel economy of the Mazda 3 just by charging it off a generator. Obviously, the Tesla's doing a lot better than Mazda 3, and the Rivian's doing a lot better than the Ford F-150 Raptor. That's not to say any of them don't have a place. You know, I really do like the Raptors, and I've owned one myself. But it really does clearly demonstrate that diesel charging with the NRMA system substantially outperforms internal combustion engines no matter what you do. That'll hold true for side-of-the-road generators, all of that other sort of stuff. So there's diesel charging trucks floating around now, that sort of stuff. I think that's really cool. It's a nice sort of side business that also means that when there are emergencies, those guys can drive out there and provide emergency power to hospitals or care centers, any of that sort of stuff. So those types of things are a really good side innovation, which has a massive social benefit. Anyway, I thought that was good to put this to bed. Have a great day.